So what exactly is pH? pH is a measurement of what we call the power of hydrogen. And I don't mean power like superhero power. I mean power like as in the power of an exponent. So the pH is actually all based on molarity, which is again the reason why this all comes back to being connected to solutions. We're measuring what's the concentration of hydrogen in the water. Okay, so we're not actually going to have to use this equation, but I'm going to use this as an example. Okay, let's say that you knew the concentration of acid was 1 times 10 to the negative 3 molar. Okay, so that means you have 0.001 moles for every liter of water. You have 0.001 moles of hydrogen. If you do negative log of 1 times 10 to the negative 3, the pH is 3. So the connection here by the power of hydrogen, the pH is just the positive exponent of the molarity. So again, let's say we had a solution with 0.01 molar hydronium. So that if we put this in scientific notation, that's 2 steps. So that's 1 times 10 to the negative 2 molar. If you put it into that equation, you get pH equals 2. So again, the pH scale number is the same as the positive exponent on the molarity. So a pH of 1 means that the concentration is 1 times 10 to the negative 1 molar. pH of 5 means that the concentration of hydronium is 1 times 10 to the negative 5. So this is, in regular numbers, this is 0.1, this is 0.00001. Okay, moles per liter. Moles per liter. Okay, so as the pH scale gets closer and closer to 7, what we're looking at here is you're getting more and more dilute hydronium. Okay, so pH way down at 1 has a lot of hydrogen in it. A pH close to 7 has very little because 0.00001 is a very small number. If we go over the 7, and we're talking about bases, okay, a pH of 11 means the concentration of hydrogen is 1 times 10 to the negative 11. That's 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 moles per liter. So now we've gone past the point of neutrality where we actually don't have enough hydrogen because this number is so small. And what's happening is as the concentration of hydronium changes, so does the concentration of hydroxide. So if you are increasing the amount of hydronium and you're getting pHs like 1 through 6, okay, then that means you have a lot of hydronium and you have very little hydroxide. If you go the other direction and you decrease the amount of hydronium, that means that you must be increasing the amount of hydroxide. So here you're going to end up with pHs between 14 and 8, okay, which means that the opposite side of the scale must be increasing. And the opposite side of the scale is the pOH. So as the power of hydrogen changes, so does the power of hydroxide. The two of them added together make 14. So for example, if you have a solution with a pH of 1, that means it must have a pOH of 13. Okay, small numbers mean a lot because what we're really talking about here is the exponent. So a pH of 1 means 1 times 10 to the negative 1 moles per liter. If our pH is that high, then that means our pOH must be very small. So this is 1 times 10 to the negative 13. So that's 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 1. Okay, so again, this is 0.1. So if we have a large number here, we're going to have a very small number on the other side. So small numbers mean small exponents, and that means the number is close to 1. If we have a big number, that means we have a giant exponent, which means our number is very far away from 1 molar. So let's say you know that your pOH is 3. Okay, well what that means is that your pH, if they add up to be 14, must be 11. So if you're asked, is this solution an acid or a base, you can either just look at the pH scale, okay, you've learned less than 7 means an acid or more than 7 means a base, okay, or if you understand what these numbers mean, okay, 11 means 1 times 10 to the negative 11 molar. 3 means 1 times 10 to the negative 3 molar. Okay, this is measuring hydroxide, and what this is telling us is we have kind of a lot of hydroxide. This is measuring hydrogen, and what it's telling us is that there's almost none. Okay, because this is 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 moles per liter, and this is 0.001. So the reason why this solution would be a base is because the pOH is much bigger and the pH is very small. So if you're solving a question like this, okay, what is the concentration of hydroxide in a solution with a pH of 4? Okay, well, we can't really get there directly with pH, okay, but what we do know is pH plus pOH equals 14. So if we know pH is 4, then that means the pOH has to be 10, which means that the concentration of hydroxide is 1 times 10 to the negative 10 molar. Okay, if we want to know the pOH of a solution with a concentration of 1 times 10 to the negative 6 hydronium, okay, well, this measures pH, not pOH. So we know the